We've got an improper integral here, right? Because we have a finite number as our lower limit, but our upper limit is infinite. So this is improper. So we're going to set this up, first of all, like this. We're going to rewrite it as the limit as b, that will become our upper limit, of e to b, right? Our upper limit is now b, of 6 over x dx. And we could take that 6 out, or we can just write this. This is going to be the limit as b goes to infinity of, right, we're going to get 6 times, now the integral of 1 over x, we know is natural log of the absolute value of x, and we're going from e to b. So let's take the limit here as b goes to infinity of 6, now I'll write it all here, 6 times the natural log of, put in the upper limit, b, minus 6 times, put in the lower limit, natural log of e. Now let's see what happens here. This is going to be the limit as b goes to infinity of 6 times the natural log of b minus the limit as b goes to infinity of 6 times the natural log of e. But look what happens here. As b gets bigger and bigger, what happens to the natural log of b? So just remember here, the natural log of b looks like this. Here's the graph of the log function. And as we go out farther, this goes up and up. So this whole thing does not exist, right? As b gets bigger and bigger, the natural log of b gets bigger and bigger. So this thing just shoots off to infinity. As b goes to infinity, the natural log of b goes to infinity. So if this is going to infinity here, it doesn't matter what this does. Some number going really huge number minus some number is still going to be really big. And this thing just goes off to infinity. We're going to say it does not exist. So I'm just going to claim now that the integral of e to infinity of 6 over x dx does not exist. And if you want to take it just a little bit further, if we graph this curve 6 over x, it looks something like this. Now, as we start here at e, 2.718, and so on, and we go out, if we're looking at area, it turns out now that the farther you go out, you're adding more area, and it actually just becomes infinitely, the area, you just get infinitely much area. In the last problem, in problem 1, we had 1 over x to the 4th, but 1 over x to the 4th, it turns out that that curve approached the x-axis much more quickly than does 1 over x.